I'm not sure. I'm afraid we need to use math.
One of the movies I really like is Finding Dory. Pixar usually does a pretty good job with whatever they do. And I loved Finding Nemo, and Finding Dory was not a disappointment for me anyways. Well, let's say that I'm trying to make a decision. Should I rent Finding Dory in high definition, or should I just outright buy it? I kind of know how many times I'm going to watch it overall. It's not something I would watch every day. It's certainly not something I would watch every month. And what I would like to know is, how can I make this decision reasonably? Well, let's set up a situation here. Let's say I already have a $5 credit on the Apple Store, which means that if I purchase anything, $5 is already there applied to that purchase. So I don't have to worry for at least $5 of it. So my question is simply this. How many times with that $5 credit, how many times would I have to rent Finding Dory until the cost begins to become greater than just outright buying it? That's the question. I want to be able to solve this reasonably. And we're going to use a two-step multi-equation in order to do this. So here's lesson 2.3, solving two-step and multi-step equations. We're talking about whether I should rent Finding Dory or am I going to watch it enough that validates purchasing it. So first, let's talk about what I know. Well, I know that a rental costs $3.99 each, and I've bolded that word each for a very specific reason. I currently have a $5 credit on my Apple account. And to purchase the film, it will cost $19.99, not counting tax. So here's what I'm going to do. I'm going to let R be the number of rentals. That's my unknown. And from this, I can get the following equation. $3.99 times R minus 5 equals $19.99. So let me explain this equation. First of all, I know that $3.99 is the rate. Why? Because of the word each. A rental costs $3.99 each. And from that key word, I know that this is a rate. So it's going to be multiplied. Also, notice that I don't see anything between the $3.99 and the R, and that implies multiplication. Sometimes we put a star or a dot there, but if you don't see it, it also implies a star or a dot. Now there's a reason my credit is being subtracted. What I'm interested in is what I'm paying out to rent this. The $5 is already there to be deducted from whatever purchase I make, and that's why the subtraction. And so $3.99 times the number of rentals minus the $5 credit equals $19.99 is the equation, the linear equation that represents this situation. So here's the equation I want to solve. How do I solve it? Well, it all boils down to one thing. Isolate the variable. Get R alone. And here's how we do it. I'm going to take the equation, and what I'm going to do is I'm going to get rid of the subtraction of $5 by adding $5 to both sides of the equal sign. The property that allows me to do this is called the addition property of equality. Now, negative $5 plus $5 is the number 0. And so I end up with $3.99 times R plus 0 equals $24.99. Now, 0 is called the additive identity, which simply means that if I add this number to $3.99R, it won't change it. Nothing changes when you add the number 0. So because nothing changes, I can drop 0 from the equation. So I now have 399r equals 2499. Now, the operation between the 399 and the r is multiplication. And I want to do the inverse of multiplication, which is division. But also, there's another thing called the reciprocal. And I don't want you to lose out on understanding what a reciprocal is. You simply take 399 and put it under the number 1. Multiplying both sides by the reciprocal is also the same as division. And the reciprocal is very important in algebra. If I can get you comfortable with the reciprocal now, algebra 2, pre-calculus, whatever, is going to be a lot easier down the road. So I'm allowed to use this multiplicative inverse. The property that allows me to do this is the multiplication property of equality, meaning I can multiply both sides of the equation by the same number. Well, here's the answer I get. R is about 6.263157895. Don't worry about all the digits after the decimal. Basically, it's about 6 rentals. So really, am I going to rent this movie more than 6 times? Conclusion, since I usually would only watch it about twice a year, I don't really think I'm going to end up purchasing it. Most likely, I'm going to borrow it from a friend. So in the Finding Dory example, I multiplied 2499 by the reciprocal of 1 over 3.99. And I want to show you how I did that. And I'm going to show you how to do that in a calculator. And so here's how we do this in a calculator. Take the number 2499. What you're going to do is you're going to multiply. And right here, do you see these 2 keys? These are the grouping keys, or the parenthesis keys. So I type a beginning parenthesis. And a fraction is nothing more than division. So I type 1 divided by 399, and then I close the grouping. And so this is how you can multiply on your calculator by the reciprocal. Hit enter, and there's the value that we got. So here's where we're going to begin today. Example 1, we want to solve the equation 10 equals 6 minus 2 times x, and we're going to check our answer. Now, to solve means to isolate the variable. So the solution will be the variable at the end, either on the right or the left, and it will just be the variable and nothing else, and the other side will be the number. So here's how we go about solving this kind of a problem. Again, to solve, we're going to use inverses. So since this is a positive 6, there's nothing in front of the 6, and so therefore it's a positive 6. What we're going to do is we're going to subtract 6 from both sides of the equal sign. So you get to subtract once from the right and once from the left. 10 take away 6 is the number 4, and 6 take away 6 is the number 0, which we don't even bother to write here because remember, 0 is the additive identity. You can drop it from the equation. Now, do you remember the operation between the -2 and the x? Since there's nothing there, we imply that it's multiplication. Now, the inverse of multiplication is either division or the reciprocal. And in the Dory example, I used the reciprocal. Here, we're going to use division. I want you to know both. The reciprocal is important. But here, we're going to use division. So we divide both sides by -2. 4 divided by -2 is -2. We're left with -2 divided by -2 is 1. And 1 is the multiplicative identity. 1 times a number doesn't change anything. And so if you have 1 times x, you are allowed to drop the 1. And we now have our solution. -2 is equal to x. Now we're going to go through the checking process. The checking process is to make sure that we really do have the answer. And the way that we know that we have the answer is we get the same number on the left and the right-hand side of the equals. And that's called an identity. So what we do is we substitute x and replace it with -2, the solution that we found. -2 times -2, well, let's ignore this negative for a moment. What's 2 times -2? It's -4. And a minus minus becomes a plus. So this actually becomes 6 plus 4, and we get 10. 10 equals 10 is an identity. It's an equation that's always true, and so this checks. Now it's time to move on to example 2. New equation, solve q over 15 minus 1/5 equals 3/5. So we're going to use some fraction operations, method 1, and then there's going to be a method 2. We're going to show you how to do that. So because in front of the 1/5 there's a minus sign, that means we're going to use the inverse, which is addition. So we're going to add 1/5 to both sides. Now, -1/5 and +1/5 is 0. 3/5 plus 1/5 is 4/5. And so we get the equation q over 15 equals 4 over 5. Now remember, a fraction is nothing more than division. So this is division. The inverse of division is multiplication. And so we multiply both sides by the reciprocal. So 15 times q over 15, what happens is the 15 here, they both divide away, leaving me with 1q, or simply q. Now, 15 times 4/5, you can multiply the 15, which is a whole number, by just the numerator, okay? Not by both numbers, just the top, just the numerator. 15 times 4 is 60. And then once you have that number, you can divide. So 5 divided into 60 12 times. And so that's the first method. The second method is we can eliminate the denominator completely by multiplying by the LCD, the least common denominator. And you see we have two denominators here. It looks like we have 3, but what I mean by 2 is this. We have a 15 and a 5. This other 5 matches this 5, and so that's why I say we have 2 unique denominators. Well, what is the smallest number that both 5 and 15 divide into? Well, it's the number 15 itself. And so if I multiply the entire equation by the number 15, by the way, that's the multiplication property of equality. You can multiply both sides of the equal sign by the same number, so long as it's not 0. So we multiply the left by 15 and we multiply the right by 15. 15 distributes, so 15 times q over 15 becomes 15 times q over 15 minus 15 times 1/5. Well, 15 times q over 15 is 1q. 15 times 1/5, remember, a whole number times a fraction. You only multiply the whole number by the numerator. So 15 times 1 is 15, and 5 divides into 15 3 times. So we're left with q minus 3. 15 times 3 is 45, and 5 divides into 45 9 times. So q minus 3 is equal to 9. Now we use inverses, add 3 to both sides, and we get the solution q is equal to 12, which matches the solution that we had before. And so there's 2 different ways that we can solve this particular equation. Now this next example has 2 parts, a part A and a part B. Sometimes you're going to have to know how to simplify before solving the equation. So let's look at the equation that we have. 6x plus 3 minus 8x equals 13. Notice I have two terms here that both have an x. These are called like terms. And so it's important before I try to solve that I simplify. So here's what I do. I'm going to use the commutative property of addition, which means that as long as I stay on the same side of the equals, I can switch the terms around. So in front of the 3 is a positive, and in front of the 8x is a negative. So when I switch them, I have to remember to keep the proper sign in front. So I switch the negative 8x to here, and I switch the positive 3 to here. And now I can simplify these two terms. 6x take away 8x is negative 2x. Plus 3 equals 13. And now I can use inverses to solve the equation. Now remember, back to this step real quick. The commutative property of addition only works as long as you're switching the terms on the same side of the equals. So here we're on the left of the equal sign. So when I switch things around, everything remains on the left. Well, using inverses here, I subtract 3 from both sides and get the number 10. This becomes the 0, which drops out. And now the inverse of multiplication is division. So negative 2x divided by negative 2 is a positive 1. So I get 1x, or simply x. 10 divided by negative 2 is negative 5. And so there's the solution. Let's go on to part B. We want to solve this equation. Now, whenever you have a negative sign written in front of a grouping or parentheses, what it really means is a negative 1 times that grouping. That's what it means to have a negative sign in front of a grouping. So what we do is instead of the minus here, we replace it with adding a negative 1 times that grouping. And then we distribute. So negative 1 times x becomes a negative 1x, or simply a negative x or a minus x. Negative 1 times 2 becomes a negative 2, and so now I can combine like terms. The 6 take away the 2. But I'm going to use the commutative property again. The 6 and the negative 2 are on the right, so I switch these terms, looking at the minus signs in front. They're both minus signs, so switching them isn't going to be a problem here. 6 take away 2 is the number 4, and now I start to use inverses. There's nothing in front of the 4, so we assume it's positive. So I use subtraction. Minus 4, and I get the number 5. And this isn't solved yet because I'm not allowed to have a negative in front of my variable. To have a negative in front of the variable means negative 1 times that variable, so I divide both sides by a negative 1. Negative divided by a negative is a positive divided by a negative is a negative. So the solution here is negative 5.